Welcome back, Network Explorers. Last time we laid the groundwork, we talked about what computer networks are, the different types, how they're structured.
Right.
We even got a glimpse of the mind-blowing scale of the internet.
It is pretty amazing.
Those incredible fiber optic cables carrying millions of phone calls all at once.
It's crazy.
But today we're getting even deeper.
Okay.
We're going to explore how information actually travels on this vast digital highway.
I'm excited.
Me too. I'm ready to put on my digital hard hat.
Okay.
Get into the construction zone of the internet.
Let's do it.
Okay, so let's break it down.
All right.
When I click a link or I send an email, what's actually happening?
Okay.
Does my message just teleport across the world?
I wish.
Right. That would be so cool.
It would make things a lot easier.
It would.
But not quite teleportation.
Okay.
But it's pretty close.
Oh, really? Okay. I'm intrigued.
So remember those data packets we talked about?
Yeah, you mentioned them.
They're back.
Okay, they're back.
And they're really the key to understanding how data transmission works on the internet.
Okay. Refresh my memory a little bit. What are data packets again?
Okay, so imagine you're sending a pizza across town.
I like where this is going.
Instead of sending one giant pie, you slice it up. You put each slice in a separate box.
Okay.
Each box is a packet.
So my email is getting sliced and diced like a pepperoni pizza.
Kind of. Digitally, of course.
Okay, good, because I don't want my email to be actual pizza.
That would be messy.
It would be very messy.
So each packet contains a piece of your message.
Okay.
Along with some important information.
Okay.
Like the address, the destination address.
Okay.
Instructions on how to put it back together.
So it knows where to go and how to reassemble itself.
Exactly.
Okay, that's pretty cool.
So then these packets, they travel across the internet.
Okay.
They hop from router to router until they reach their destination.
Okay, so the routers are
Think of them like little post offices.
little post offices.
So they're sorting the packets, figuring out where they need to go next.
They're reading those little digital addresses.
Exactly.
That's pretty cool.
Each router uses something called a forwarding table.
Forwarding table.
It's basically like a map
Okay.
that tells the router which path to take to get that packet closer to its destination.
Okay, so it's like a giant postal service, but digital.
Yeah, a really, really fast postal service.
I like that analogy. But just like a postal service, the internet can experience delays, right?
Yep, unfortunately.
And why does that happen?
Well, if a router gets flooded with too many packets all at once, then those packets, they have to wait in a queue.
So it's like when my internet slows down.
Exactly. It's like digital rush hour.
Ugh, I hate digital rush hour.
All those packets are stuck in traffic.
I hate being stuck in traffic.
Nobody likes traffic.
No. So is that it? Or can it get even worse?
Well, sometimes if that queue gets too long, packets can even get dropped or lost.
Gasp. Like a letter getting lost in the mail?
It happens occasionally.
Oh, no. Is there anything that can be done to prevent that?
Yeah. So network engineers, they're constantly working on ways to optimize traffic flow and prevent congestion.
Okay, good.
They're developing new routing algorithms, increasing bandwidth, implementing all sorts of fancy techniques to keep that data moving smoothly.
So they're constantly building new highways?
Yeah.
New traffic management systems for the internet?
Pretty much.
Wow, those engineers have their work cut out for them.
They do. It's a tough job, but somebody's got to do it.
Right. So we've talked about this whole packet switching thing. Is that the only way to send data, or is there another way?
You're actually onto something.
Oh, really?
There's another method called circuit switching.
Circuit switching. Okay, I've heard that term before.
A little bit different. So with circuit switching, it's like having a dedicated phone line.
Okay.
Just for your conversation.
Okay.
So a direct connection is established between the sender and the receiver.
Okay.
Before any data is even transmitted.
So it's like reserving a lane on the highway just for your car?
Exactly. No merging with traffic.
Ooh, very fancy.
Yeah, so circuit switching, it guarantees a certain level of quality and bandwidth, but it can be less flexible than packet switching.
Okay.
Especially when it comes to what we call bursty data traffic.
Bursty data traffic. What's that?
So imagine you're browsing the web. You click a link. Burst of data is transmitted to load the page.
Okay.
Things quiet down until you click another link.
Right.
So it's not a continuous stream of data.
Okay.
It's these short, irregular bursts.
Bursts of data.
Exactly.
Okay, so packet switching is more adaptable to the way we actually use the internet?
Yeah, for sure.
Okay.
It's like a flexible carpool system.
Okay.
Cars can join and leave as needed.
I get it. That's a great analogy.
So But that doesn't mean circuit switching is totally obsolete.
Right.
It still has its uses.
Okay, what kind of uses?
For applications that need real-time communication.
Real-time communication.
Like voice calls.
Oh, okay.
Video calls.
Makes sense.
Things like that.
Okay.
That's why technologies like VoIP, Voice over IP,
right.
They often use like a hybrid approach.
Okay.
Combining the best of both worlds.
So it's like a car that can switch between highway and city driving modes.
Exactly. Adapt to the conditions.
That's pretty cool.
Pretty neat.
So we've covered how data travels across the internet, but now I'm curious about like how we, the users, actually connect to this whole thing.
Right. So we're going back to the network edge.
Back to the suburbs.
Back to the suburbs where we live.
Where all the action happens.
Exactly.
And there are a variety of ways to access this digital world, right?
Oh, yeah. Absolutely.
Yeah. Okay, so let's break it down. What are like the different options for home internet access?
Okay, so you've got your usual suspects.
Okay.
Cable, DSL,
okay,
fiber optic.
All right.
Each one uses a different technology to connect your home to the internet service provider, or ISP.
Okay.
It's kind of like choosing a transportation method.
Okay, I like this analogy.
For your daily commute.
Okay.
You could take the bus, the train, drive your car, ride a bike, so many options.
Right, so many options. So choosing my internet connection is like choosing my ride to work.
Exactly.
Got it. So what are the pros and cons of each option?
So cable internet.
Okay.
It's super popular because it's widely available.
Yeah, that's true.
Offers decent speeds.
Okay.
But it's a shared network.
What does that mean?
So that means speeds can slow down during peak hours.
So like rush hour on the freeway?
Yeah, when everybody's trying to stream Netflix at the same time.
Ugh, that's so annoying.
It is frustrating.
Okay, so what about DSL?
So DSL uses existing telephone lines.
Okay.
So it's often more affordable than cable.
Right.
But it can be slower and less reliable.
So slower and less reliable.
Yeah, it's kind of like taking the back roads instead of the highway.
Got it. So cable is faster but can get crowded. DSL is slower but might be more reliable.
Yeah, it's a good summary.
Okay, what about fiber optic?
Ah, fiber.
I keep hearing that's like the holy grail of internet connections.
It's definitely the speed demon.
Okay.
Blazing fast speeds.
Yeah.
High bandwidth.
Okay.
It uses pulses of light to transmit data, remember?
Yeah.
It's like having a private jet for your internet connection.
Sign me up.
But it can be pricey.
Okay. Yeah.
And it's not available everywhere yet.
Right.
But if you're a heavy internet user and fiber is an option in your area, it's definitely worth considering.
Okay, so for people who live in rural areas where cable and fiber aren't available.
That's where satellite internet comes in.
Satellite internet.
It's a good option for those hard-to-reach places.
Okay.
But it can be expensive and have high latency.
Latency again? Remind me what latency is.
Latency is the delay between sending a request and receiving a response.
Okay.
It's measured in milliseconds. The lower the latency, the better.
So for things like video calls, online gaming, you want low latency.
Absolutely. High latency can be super frustrating, makes everything feel slow and sluggish.
Yeah, like you're talking to somebody and they take 5 seconds to respond.
Exactly.
The worst. Okay, so we've talked about home internet access.
Right.
What about mobile networks?
Mobile network.
How do our smartphones connect to the internet?
So mobile networks use a different technology.
Okay.
Called cellular technology.
Cellular technology.
Instead of cables, they use radio waves.
Radio waves?
To transmit data between your phone and cell towers.
Okay, so it's like a network of invisible hotspots.
Yeah.
Covering the entire country.
Pretty much.
That is really cool.
It is a pretty amazing feat of engineering.
It is.
When you think about it.
So that's where 5G comes in.
Bingo.
Okay.
5G is the latest generation of cellular technology. It promises significantly faster speeds.
Oh.
Lower latency.
Okay.
Greater capacity than previous generations.
So it's like upgrading from a dirt road to a superhighway for mobile data.
Yeah, that's a great way to put it.
That's pretty exciting.
It is exciting, yeah.
Like self-driving cars and all that.
Yeah, 5G is going to enable all sorts of new technologies and applications.
That's awesome.
It's a very exciting time to be following technology.
It is, but even with all these advancements, I imagine there are still physical limitations to, like, transmitting data, right?
Oh, yeah, absolutely.
Okay.
Whether it's cables, radio waves, even light pulses.
Right.
There are always challenges to overcome.
Okay, so what are those challenges?
Well, you've got signal interference.
Okay.
Distance limitations. Even the speed of light itself.
Oh, wow.
That's a big one.
It is a big one.
So engineers have to consider these factors when they're designing networks. trying to make everything work smoothly.
So it's like a constant battle to make the internet faster, more reliable, more accessible to everybody.
It's a never-ending quest.
It's a quest for better connectivity.
That's it. That's the quest.
I like that. I'm glad there are people out there who understand this stuff.
Me too. I'm glad they're doing their job.
Yeah, me too, because I don't.
Yeah, it's pretty complicated stuff.
Okay, so we've covered a lot of ground in this part.
We have.
We talked about how data travels in packets.
Right.
The different ways we access the internet.
Uh-huh.
It's amazing to think about all the complexity that goes on behind the scenes.
It really is mind-boggling.
Every time we click a link or send a message.
Yeah, you don't even think about it.
You really don't.
But it's happening.
It's all happening.
All the time.
All the time. And we've only just scratched the surface.
Oh, yeah.
There's still so much more to explore.
Like those all-important internet protocols.
Oh, yes, the protocol.
They're the unsung heroes of the internet.
Okay, you've definitely piqued my curiosity.
Right.
I'm ready to learn more about protocols.
All right, we'll delve into those protocols in part 3.
Okay.
Uncover even more secrets of the digital world.
I can't wait. Everyone stay tuned for part 3. Welcome back to the final part of our deep dive into computer networks.
The grand finale.
I know, it's gone by so fast.
It has.
So we've explored this vast landscape of the internet.
We have.
We talked about those mind-boggling fiber optic cables, the bustling data centers, all the different ways that we connect to this digital world.
So many different ways to get online.
I know. It's really amazing.
It is.
So we've uncovered so many fascinating details about how the internet works. But now I'm curious about, like, the so what factor.
The so what?
Yeah, like, why should anyone care about, like, all the nuts and bolts of computer networks?
It's a good question.
Yeah, what's the takeaway for the everyday internet user?
Well, I mean, think about it. We live in an increasingly interconnected world.
That's true.
Right. Where almost everything we do relies on the internet in some way.
I can barely remember life before smartphones and Wi-Fi.
Exactly.
It's kind of scary.
A little bit.
But understanding how networks work empowers you to make informed decisions about your own digital life.
Exactly.
Okay.
From choosing the right internet provider to troubleshooting your home Wi-Fi.
Right, because nobody wants to be stuck on hold with tech support forever.
Nobody.
So this knowledge can save you time and money.
It can.
A lot of frustration.
Definitely a lot less frustration.
Okay, good.
And it also makes you a more critical consumer of information.
Oh, that's interesting.
Right. When you understand how data travels online, you're less likely to fall for scams or misinformation.
That's a good point. It's like knowing the rules of the road helps you avoid accidents.
Exactly.
Okay.
And let's not forget the sheer wonder of it all.
Oh,
billions of devices communicating across continents at lightning speed.
It's pretty magical when you think about it.
It is.
And it's constantly evolving, too.
Constantly, with new technologies and applications emerging all the time.
Yeah, so it's kind of exciting to be a part of it.
It is.
Speaking of evolution, you mentioned those internet protocols.
Yes.
They're like the unsung heroes that keep this whole system running smoothly.
They really are.
Okay, remind me what protocols are.
Okay.
And why they're so important.
So think of protocols as the language of the internet.
Okay.
They're a set of rules and standards that dictate how data is formatted, transmitted, and received, ensuring that all those different devices and networks can actually talk to each other.
So like a universal translator for the digital world.
Exactly.
Can you give me some examples of these internet protocols in action?
Oh, yeah, absolutely.
Okay.
So let's start with HTTP.
HTTP.
Or Hypertext Transfer Protocol.
Okay, I've heard of that one.
This is the protocol that governs communication between web browsers and web servers.
So every time I type a URL into my browser, I'm actually sending an HTTP request to a server.
You got it.
And then the server responds.
With an HTTP response.
Which contains the web page content.
Exactly.
So it's like a digital conversation between my browser and the server.
Yeah.
All thanks to HTTP.
All thanks to HTTP.
Okay, I'm starting to see the language analogy here.
Good.
What about TCP?
TCP.
You mentioned it's responsible for, like, reliable data transmission.
Yeah.
What does it actually mean?
So TCP, or Transmission Control Protocol.
Okay.
It's like a super reliable postal service.
Okay.
For the internet.
Right.
It ensures that data is transmitted accurately and completely.
Okay.
Even if some packets get lost or arrive out of order along the way.
So it's like a guaranteed delivery service for our digital packages.
Yeah.
No matter what obstacles they encounter along the way.
Exactly. TCP uses a system of acknowledgements, and retransmissions.
Okay.
To make sure that every packet arrives safely at its destination.
Wow, that's really impressive.
It's pretty cool.
I never realized there was so much going on behind the scenes.
Oh, yeah. There's a lot happening.
So just to make sure my downloads and uploads work properly.
A lot of unsung heroes working behind the scenes.
Keeping the internet running smoothly.
And it's not just about reliability.
Okay, what else?
TCP also handles things like flow control.
Flow control.
Making sure that the sender doesn't overwhelm the receiver.
Okay.
With too much data at once.
So it's like a traffic cop for the internet.
Exactly.
Making sure everyone's following the rules.
Uh-huh.
Keeping things moving smoothly.
Yeah, a very important job.
Okay, and then we have IP.
IP.
Internet Protocol.
Internet Protocol.
That handles the addressing and routing of packets on the internet.
Exactly.
So IP is responsible for those long strings of numbers that we see as IP addresses. Like a digital street address.
Yeah, like a digital fingerprint.
For every device on the internet.
Exactly. Every device connected to the internet has a unique IP address.
Okay.
Allows it to be identified and located on the network.
Okay, so it's like a digital fingerprint that distinguishes your device from all the others.
Exactly.
Okay, I'm starting to see how all these protocols work together to make the internet function.
It's a beautiful thing.
It really is.
It's like a well-oiled machine.
It is.
With each part playing a crucial role.
And the beauty of it is that these protocols are open standards.
Yes.
Meaning that anyone can use them.
Exactly.
This has fostered incredible innovation and collaboration.
It has.
Leading to this amazing diversity of the internet.
The internet that we know and love.
It's like a global community.
It is.
All speaking the same digital language. Working together to build something truly incredible.
And it's constantly evolving.
It is. It's like a living, breathing ecosystem. Constantly adapting and growing to meet new challenges and opportunities.
Exactly.
It's kind of beautiful.
It is when you think about
it. In a nerdy kind of way.
In a nerdy way, yes.
But that's what makes it so exciting to be a part of.
It does.
Right? There's always something new to learn and explore in this world of computer networks.
Well, I definitely feel like I've gained a whole new appreciation for the internet and all those intricate systems that make it work.
Yeah.
It's easy to take it for granted.
It is very easy.
But there's so much ingenuity and collaboration happening behind the scenes.
All the time.
Yeah.
It's really remarkable.
And the best part is...
That's the best part.
This journey of discovery is just beginning.
Ooh. I like that.
As technology continues to advance. Who knows what amazing new innovations await us?
That's true. That's the beauty of technology.
It is.
There's always something new to learn and explore.
Always.
So to our listeners, we encourage you to keep that spirit of curiosity alive.
Stay curious.
The internet is a vast and ever-changing landscape.
It is.
Full of wonders waiting to be discovered.
Definitely.
Thanks for joining us on this deep dive into computer networks.
It's been a pleasure.
Until next time.
Yes.
Stay curious.
Stay curious.
And keep exploring.
Keep exploring.
A fascinating world of technology.
And remember, the internet is more than just cat videos and social media.
That's right.
It's a powerful tool that can connect us, educate us, and inspire us to create a better future.
Well said. We'll see you next time, everyone.
Bye.